Um, Good evening, everyone. Thanks for joining the session on pathways to decarbonization, modeling Tamil Nadu's power sector decarbonization by Umesh Ramamurthy, senior researcher at Aurovile Consulting. This session is a part of the Sustainable Energy Transformation or SET project, which is done in collaboration with the World Resources Institute and Citizen Consumer and Civic Action Group. Without further ado, I hand it over to Umesh, who will be starting the presentation. Thank you.
Okay, thank you, Radhika, for your introduction. I hope I'm loud and clear. Welcome everyone for this presentation. The topic is Pathways to Decarbonization. It's about modeling Tamil Nadu's power sector decarbonization. First of all, we would like to know what decarbonization is. Decarbonization is reducing carbon dioxide emissions resulting from human activity. What will happen if we reduce the carbon dioxide emissions? The reduction of global emissions of carbon dioxide will limit the increase in global temperature. This addresses the concerns of global warming. At COP26, India announced its ambition to become a net zero emitter by 2070. And why decarbonization of power sector? 7% of global carbon dioxide emissions are from India, of which 45% of the emissions are from the power sector alone. You see the charts here. Yeah. So this calls for the decarbonization of power sector in India. And why decarbonization of Tamil Nadu's power sector? Yeah. When we talk about decarbonization of India as a whole, we need to look at sector specific and state level targets and action plans to decarbonize the entire India. So Tamil Nadu is a small piece in the bigger puzzle. So we need to decarbonize Tamil Nadu's power sector to achieve the bigger goal of decarbonizing India. Also, electricity generation in Tamil Nadu, like elsewhere in India, is highly dependent on coal. The electricity generated from fossil fuel-based power plants contributed to 76% of total energy generation in 2020. We will look at some statistics that will convince us why we need to decarbonize Tamil Nadu's power sector. Here are some statistics. So here is the electricity supply for the state of Tamil Nadu. This is for the year 2020. As of on 2020, we had consumed 77.55% of fossil fuel based electricity, and the remaining 22.45% came from renewable and clean energy. So in spite of Tamil Nadu being one of the leaders in renewable energy, we are still dependent on fossil fuel based energy for our consumption. Where is all the consumption go? So here is the electricity demand for the state as of 2020. Industry and domestic put together constitute 68.8% of the total electricity demand. Agriculture 14.95%, commercial 9.59%, and others 6.64%. So here is the electricity demand coming from. So what we could clearly take away from this slide is that Tamil Nadu is still dependent on fossil fuel based electricity for its consumption. So this calls for decarbonization, and we did a modeling exercise in this work to understand how it would look like if we set a series of targets for us year on year, and if we are there to it, what will it do to the electricity generation in Tamil Nadu, and what it will do to the carbon dioxide emissions. To start with that exercise, we had to set an year as a baseline and an year for the target. So we set 2020 as the baseline year for this work, and we set 2050 as the year to achieve a zero carbon grid for the state of Tamil Nadu. We all know that India pledged that it will go net zero by the year 2070, but we set 2050 for Tamil Nadu's power sector for a reason. And the reason is that Tamil Nadu is already a leader and pioneer in the renewable energy sector because more than 50% of Tamil Nadu's total installed power capacity comes from renewable technologies. And also, the policy announcements such as the planned capacity addition of 20 gigawatt solar by the year 2030 highlight the state's long-term renewable energy ambitions. So Tamil Nadu is better positioned than many of the Indian states to have a zero carbon grid by 2050. So for this exercise, we assumed Tamil Nadu would go net zero in its power sector by 2050. And the next exercise is forecasting the generation of electricity for Tamil Nadu. In this, we know that Tamil Nadu's electricity generation is 1,05,146 million units in 2020, and we forecast it to increase by 3.6 times to 4,89,395 million units by 2050. For this generation forecast, we didn't take the energy mix into consideration, such as how much will come from renewable energy, how much will come from, say, for example, hydro or coal or lignite. We didn't take that into consideration because 30 years from 2020 is a long time, and there might be a lot of technologies that might come and go. So we just did the generation forecast without taking the energy mix into consideration. And with the help of the forecast, we tried to project the emissions for the future. Along with that, we also calculated the historical emissions. That is, the historical emissions for the state of Tamil Nadu from its power sector happens to be the emissions from Tamil Nadu's power sector have decreased by 7% between 2010 and 2020. That is mainly because of the penetration of solar rooftop installations that happened between 2015 and 2020. So there is a reduction in emission by 7%. But then what will happen from 2020 is a different story. We forecast the emissions also to increase from 50.97 million metric tons of carbon dioxide to 237.27 million metric tons in 2050, which is an increase of 365%. So this is the emission projections. We call it as the BAU scenario or the business as usual scenario. That is, what if we emit the way we are emitting right now without doing anything about it. So this is the emission projection. So if we have to intervene and set some targets for the power sector of Tamil Nadu, and also if we adhere to the targets, what will happen? That is a question in everyone's minds. So we decided to go with science-based target setting. Science-based target setting, within the science-based target setting, there is something called as a sectoral decarbonization approach, which gives a carbon budget to each and every country, and within the country, it will give a carbon budget to each and every sector, such as the power sector, transport sector, and all the other sectors. So we took that approach, and we wanted to set targets for the power sector of Tamil Nadu. And it looks like they have two different pathways to decarbonize the power sector of Tamil Nadu, and both of them are aligned with the goals of the Paris Agreement. One is called as the ETP B2DS pathway. The other one is called the SBT 1.5 degrees Celsius pathway. What is this SBT 1.5 degrees Celsius pathway? This is a pathway that limits the global warming by 1.5 degrees Celsius. If Tamil Nadu's power sector has to follow this pathway, it requires a decrease of 72% in Tamil Nadu's total emissions by 2030 and 100% by 2050. If Tamil Nadu has to adhere to Tamil Nadu's power sector has to adhere to the ETP V2DS pathway, then that limits the global warming well below 2 degrees Celsius, which requires a 37% decrease in total emissions by 2030 and 100% by 2050. So our target for Tamil Nadu's power sector is the year 2050. We can also think about stretching this target a bit beyond 2050, say, for example, 2060 or 2070. But then the carbon budget allocated to this particular sector, that is the power sector of Tamil Nadu, is limited. And that will not change whether we set the target 2050 or 2060. So if we set the target further from 2050, that is 2060 or 2070, then we need to follow an aggressive pathway in the first 10 years and eventually leading to a net zero by 2060 or 2070. So it is about the carbon budget. It is like somebody is given a 100 rupee note to spend. Whether to spend it before 2050 or 2060 is that individual's choice. Irrespective of when the person wants to run out of the money, the magnitude or the quantum of the money remains the same, which is 100 rupees. So that is how you can explain carbon budget. So this is setting science-based targets. Yeah, and we wanted to also look at how it will look like when we stick to the business as usual scenario. When we stick to the business as usual scenario, the cumulative emissions from the power sector of Tamil Nadu by the year 2050 would be 3,779 million metric tons of carbon dioxide. So we would have emitted that much by 2050 cumulatively. And if we do a good job and stick to the ETP B2DS scenario, that is linking the global warming below 2 degrees Celsius, then we would have cumulatively emitted just 702 million metric tons of carbon dioxide. If we do a better job and stick to the SBT 1.5 degrees Celsius scenario, that is limiting the global warming well below 1.5 degrees Celsius, we would have cumulatively emitted just 455 million metric tons of carbon dioxide by 2050. You could clearly see the difference between how it is when we conduct ourselves in a business as usual way and how it is how the emissions are when we conduct ourselves adhering to one of the science-based pathways. And next is, we wanted to compare few models that we have created for the year 2030 and how they look like. So 2030 is closer to us already. So we wanted to see the cases for 2030. If we conduct ourselves in a business as usual way, we would have just, the power sector of Tamil Nadu would have just 16% of its electricity coming from renewable sources, which is the business as usual scenario to your extreme left. And then if we follow the RPO scenario, RPO is renewable energy power purchase obligation. This is a mandate given by the Ministry of Power to all the states. So as per that mandate, all the states should have at least 43% of its electricity generation coming from electricity generation or purchase coming from renewable energy resources. And if we had to stick to the ETP B2DS pathway, we should have at least 57% of the electricity coming from renewable energy resources by 2030. And if we have to follow the SPT 1.5 degrees Celsius scenario, we should have at least 81% of the electricity coming from renewable energy resources. So now we will see what happens to the emissions for each and every scenario, given that they have this certain percentage coming from renewable energy. So here is how the emissions look like. If you are in the business as usual scenario to the far left, Then 16% comes from 16% of electricity comes from renewable energy, and we would have emitted 591 million metric tons of carbon dioxide by 2030. If we stick to the RPO scenario and have 43% of electricity from renewable energy, then we would have emitted 383 million metric tons of CO2. The same way for ETP B2TS, we would have emitted 327.27 million metric tons of CO2, while having 57% of electricity coming from renewable energy. The same goes for SBT 1.5 degrees Celsius as well. If we clearly look at it, the emissions decrease as the percentage of renewable energy increase. So it is up to us to which one of these scenarios we stick to. Yeah. So even if the RPO scenario is closer to at least one of the science-based target methodology, which is ETP B2TS. So concluding this work, what we could take away from this is we have to follow the SBT 1.5 degrees Celsius scenario. We would have to decrease the emissions by 72% by 2030 and 100% by 2050. ETP B2DS scenario, we would have reduced the emissions by a 39% by 2030 and 100% by 2050. Of these two, SBT 1.5 degrees Celsius scenario, the form at the top, seems to be an aggressive pathway towards decarbonization. And then finally, even if we couldn't meet any of these scenarios, we could at least stick to the policy announcements of the government and the renewable energy purchase obligation given by the Ministry of Power, which is closer to one of these pathways. So that would at least lead the power sector to decarbonize to a certain extent. So that is all my presentation. If you have any questions, I would answer. Thank you.
Thank you, Umesh, for your presentation. If anyone has any questions, please raise your hand, or I can unmute all of you, and you can all ask any questions that you may have. Are there any questions, or can we conclude the session?
Or maybe any feedback?
Hi, I think it was pretty clear, the session, and I was able to understand the concepts quite clearly. It was also nice to see like some projected scenarios.
Projected scenarios of emissions, you mean, or?
Yeah, both in terms of emission and like at what rate we need to function and in order to control it.
Okay, so in this, these are the scenarios. These are scenarios by itself. If we conduct ourselves in the same way we are doing right now, which is a business as usual scenario, we will be just left with 16% of renewable energy in our electricity share, and that would have contributed to 591 million metric tons of CO2 just for the year scenario, which is the baseline or the business as usual scenario. If at all we stick to the renewable energy power purchase obligation scenario. That is, the Ministry of Power wants Tamil Nadu to have at least 40 energy in its energy mix by 2030. If they stick to that, the emissions come down to a certain extent. Yeah, so that is another scenario. We all have, I mean, so these are different scenarios by themselves. Yeah. So also the graph you have seen before, which is the cumulative emissions. So what if we do a good job and limit our what if we add more renewable energy into our energy mix and limit the emissions as per the science target setting methodology is given here in the bottom. So that is the ETP B2DS and the SPT 1.5 degrees Celsius. So that says, what if we adhere to one of the methodologies, and what if we do not have anything to follow? That is, we just conduct ourselves the way we are conducting us right now. So that's the business as usual scenario. So the difference itself says there is a gap. There will be a gap in the emissions as huge as the graph says. So, and also we would have very less renewable energy mix in our electricity. So I think these are the scenarios. If you would like to mention specifically what you would like to see, probably I would try to answer that.
No, actually, I was just saying that these scenario-based slides were very useful. Like, was able to understand better.
Okay. Yeah.
Thank you, Priyanka, for that feedback. I will be sharing the presentation as well as the recording of the session with you. So if you have any further questions, you can reach out to Umesh, and yeah. Thank you for attending, and yeah, have a great weekend ahead.
Thank you, everyone.
Thank you.
Yeah, all right. Umesh left as well.
Okay.
It's fine. So then we check in on Monday.
Yeah, 1 minute. I'll just pause the record.